Hey, what's up guys? Welcome back to the channel. And in today's video, I'm going to be talking a little bit about how code is organized in the .NET framework, and it's contained languages such as C#. So in the last video, you guys saw me just setting up a basic project, and I have a hello world program here. I've created a namespace, a class, and a method. I'll talk about all those in a second. And I'm just writing hello world to the console. If I actually run this project, it's going to take a minute to compile, but then we'll see the output, which is hello world. So this is the basic program, but before we move on, I'm going to show you a little diagram I created which shows you how code is basically organized in .NET. So at the top, we have an assembly. And an assembly is the binary file, or the basic binary unit of .NET code. So this is what all your code is compiled to. It's compiled to a .NET assembly. And these assemblies, they do have a DLL extension. However, all the code within them, all the .NET code within them that you write for the .NET runtime or the CLR is known as managed code. And all the code that's written outside of that runtime, so let's say you wrote a program in C, that's known as unmanaged code. And all the code in this DLL as of now, so the project that I just compiled, is managed. And you're not able to actually load that code from an unmanaged context. So if I went and made a C program right now, I couldn't call load library on this DLL. I mean, I could, and I might be able to load it, but I wouldn't actually be able to access my program, class, or the main methods. So this DLL is specially created and can be specially loaded by the CLR, the Common Language Runtime for .NET. Next, each assembly contains some types or some classes. So I've detailed that here. There could be different classes. I've accidentally named them both class A, but pretend these two have different names for now. So each assembly contains multiple types, and you saw in my program, if I bring this out of the way, program right here, that is my type. That is the type that I have in this assembly. So this is a class. And these types are contained within namespaces. So obviously you can see here, this is contained within the test project namespace, which I've outlined at the top. And I could change this freely as I want. I'll expand project here, and you'll see it's reflected down here with my IntelliSense. But I could change all these namespaces. But that's the basic gist of it. Assemblies contain types. And then types contain methods. So methods are where the actual code resides. So there's no code, like intrinsically, if you think about a C program, you can't write code outside of a function. If you need some logical operations to be done, they must be inside a function. And the same idea applies here to .NET, where all of the actual code, all of the things that are running within the assembly are contained within these methods. And I'll show you that again, where within my type, I have a method. And within this method, I have some code. So the gist is assemblies contain types, which contain methods, which contain code. And this is my code. I'm just calling another method console.writeLine. So I've showed you the type, the class, and the method, main, but I haven't actually showed you the assembly. But it's actually right here, testproj.dll. So you might have noticed I used .NET Run to run this project, and that's just since I have this .NET project set up, I can use that command. However, if I just ran .NET Run out here, it couldn't find a project to run. However, .NET will execute any .NET DLL or assembly that you pass to it. So if I drag my testproj.dll right here, it'll actually execute that. So that's a pretty cool thing. And I'll show you a little assemblies a little more in depth by creating another assembly. So what we're going to do is we're going to do .NET new class lib, and I'm going to name that test lib. I'm just going to get some IntelliSense by adding this to the solution. That's good. It's added to the solution. And now I have this class 1, and it's within the namespace testlib. Let me just write a function public int add. And let me make this static so I can call this without an object context. And I'll take x and I'll take y. You don't have to know what any of this means right now. I'm just using this as a conceptual example. So I have an add function within the type class 1. So again, we have that assemblies contain types, contain methods, contain code, and all it does is it takes two integers, adds them, and returns them. And now what I can do is, if I go back to test project, sorry, wrong place, go back to test project, I can actually add a reference to the assembly, my other assembly test lib. So let me add a reference right there. I now have that assembly reference. And if I run this program again, actually, let's actually call that function. So we know we had our project reference. And I'll show you, this is also a nice way to learn how namespaces work. I now have access to my test lib namespace, which was defined in my other project. If I now do test lib, I can see the class 1 class because it's public. So I'll now do class 1, and I have the add method. Add 1 and 2. Let me store this in a variable, and res equals this. And instead of writing hello world, I'm just going to console.writeLine this. So we've now called our add method, but there is actually a way to shorthand this. So if I just write class 1, you'll notice my extension, the C# devkit, actually added this using statement at the top. What this does is it tells the compiler, hey, I'm going to be using a lot of things from testlib, this namespace. Let me just use all of them in the current context without having to say testlib all the time. So it'll take this namespace, whatever's in it, you can now use without having to say testlib dot at the beginning. So before I had to do this, but now you can notice it's grayed out and it's saying name can be simplified, because I've already used testlib in my code. So I can just remove that, and this is allowing me to just reference class 1 as if I was within the testlib namespace. But aside from that, I can go ahead and run it and wait for it to compile. And you can see it wrote out 3. The correct answer, 1 plus 2 is 3. And we'll look at the binary directory to look at what's happening here. So you can see there's a couple more things in this folder now. Originally, I just had testproj, which was my assembly, but now I have testlib. And testlib is that other assembly that was compiled from this project right here. And within this assembly, we have one singular type, class 1, and one singular method on the type, add, within the testlib namespace. So right now, my testproj is referencing the testlib assembly to get access to different types, such as class 1. I'll show you that it's dependent on that assembly now. So testlib is a dependency of testproj. I'll show you by using our .NET command earlier. I told you that I can just run any .NET assembly right here. You'll see that if I actually pass in testlib, you'll notice it says it's not a self-contained app. That's because I compiled testlib as a class library project, so this can only really be used as a dependency, but I'll show you that test project does require testlib by just removing it. And now, if I try to run test proj, there's an exception because it can't load one of the assemblies it needs as a dependency. So that's pretty cool. And so that's basically the gist of assemblies and classes and types. So basically, assemblies are the binary unit of .NET, and they contain all the code, all the types, everything of basically one .NET project. And within assemblies, there are types. And types are quite literally types, data types of objects that you can create, but they're also containers for methods. And methods are just functions, different pieces of reusable code that you can call, and within those methods you have code. And that's the actual code, the logic of your .NET application. So thanks for tuning in to today's video. If you have any questions or comments, leave them down below in the comments, and I'll see you in the next one.